Alright, last thing I want to do is show you two shortcuts for division and the division process, which we'll be using this whole process of division again when we get to chapter 4 and we start dividing, we start finding the roots of polynomials. So that's kind of why we're doing this whole division thing now. But here are a couple shortcuts. The first shortcut does not work all the time. So shortcut 1, shortcut 1. I don't know, my pen's going crazy today. Shortcut number 1. Now, it only works sometimes. Okay, it doesn't always work. Otherwise, this would be the best way to do it. What you can do is you can rewrite this as a rational expression. So you can put x squared plus 2x plus 1 on the top, and you could put x plus 1 on the bottom. Now, if this is going to work for you, two things have to be true. First of all, you have to be able to factor the top, which I think you guys all know that we can. So that part is okay. Now the other thing that has to be true is if you can factor the top and bottom have to have a common factor. Boom, boom, I guess they do. I get x plus 1 with no remainder. Obviously there's no remainder because if there was a remainder I couldn't do the problem this way. So that's one shortcut. The second shortcut is you can do a process called synthetic division. So what you do for synthetic division is, so here's shortcut 2. This one will work a little bit more often for you. It still doesn't work all the time. It's called synthetic division. Now, if this is going to work for you, what has to be true is you have to be dividing by something that looks like this, x minus a, where a is a number. So you can't have anything in front of the x. Maybe you can factor something out of the x and deal with it that way. That can be kind of tricky sometimes. So I only do this if I have nothing in front of the x and I'm subtracting a number. Can't have x squared or x cubed. It's got to be just x. Now here's what you do when that happens. You draw a box, and whatever number you see here, since I'm supposed to have a minus here, if I don't have a minus, then I have to think of my a as being negative. So I can actually think of this as being x minus negative 1. Now I can use synthetic division, and my a is actually going to be a negative number. Basically, the shortcut is whatever sign you see here, put the opposite in your box. Then you take every coefficient and just write them out. Now, if there are any that are missing, make sure you put a 0 there. So if I didn't have a 2x there, I have to put a 0 there. I can't just leave it blank. It's more important than ever to add your zeros in doing synthetic division. So I have this, and then I draw a line. And now, because I've changed this sign and made it the opposite, I bring down, and I can multiply, and then I can add instead of subtract. So negative 1 times 1 is negative 1, and then I add the columns. I get 1. Negative 1 times 1 is negative 1, and I add the columns. I get 0. Now, this was my x squared column. This was my x column. This was my number. When you use synthetic division, everything's been reduced by 1. So this is now the x column, and this is now the number column, and this is now your remainder. So my final answer, I have 1x, which I'll just write as x, and then I have a 1 for the number, so plus 1, and no remainder. And as you can see, those two answers are exactly the same, and that's just what I expected. Now, some of you may not like synthetic division. I want to highlight this, and it's not going to let me highlight it. Oh, it's thinking about it. Okay, let me highlight my answer here. Now, some of you may not like synthetic division, but just to show you how quick and easy it is, let me do one more problem. I'll just make this one up, and randomly and see what happens. So let's say that I want to divide x to the 5th minus x squared plus 2x minus 3, and I want to divide that by x plus 5. Okay? Now I have no idea how this is going to work out, but I can tell you if I was doing long division, I'd have a lot of steps and I'd take a lot of room on my paper. But here it's going to be much easier. I draw my box. Whatever sign I see here, I reverse. Now when you set this up, be careful. I have 1x to the 5th 0x to the fourth, don't forget the zeros, 0x cubed, negative 1x squared, 2x, negative 3 is my number. Draw my lines, and then bring down, multiply, and add. So bring down, negative 5 times 1, negative 5, and add. The reason I can add is because I changed my sign here at the beginning. So I add, I get negative 5. Here I get 25. Bring down. Ooh, this is going to be big. Negative 5 times 25 is negative 125. And then bring down. So now I have negative 126, right? Okay, so negative 5 times negative 126 is going to give me positive 630. Bring down, I get 632. Negative 5 times 632, well, let me use my calculator on that. Okay, I get negative 3,160, and then I add, I get negative 3,163. So this is now my x to the fourth, so I have x to the fourth, minus, this is my x to the third, so 5x to the third, and then plus 25x squared, minus 126x, plus 632, that's my number, and my remainder, which I will write in the form that I want to write it in, is going to be plus, and then I have negative 3,163 over x plus 5. Now, this looks like a really big, ugly problem, but I can tell you from experience, it would have been a nightmarishly more difficult problem if I had not used synthetic division. So synthetic division, kind of a nice thing. When you get good at it, you get fast at it, you can like go home and race your friends and, you know, do some synthetic division problems, you know, when you're hanging out and don't have anything to do, TV's not working, or, you know, who needs TV anyhow if you have synthetic division. So I hope you enjoyed this.